This is Formula and Equation Video 1. This is going to be just an introduction to naming and how to write names for different atoms and ions. So let's just review what atoms and ions are. I know we talked about them in the atomic structure unit, but just in case you forgot, remember that an atom is electrically neutral, meaning that it has the same number of protons and electrons. So whenever we saw the word atom, we would annotate it and we would write neutral so that we remember that it didn't have a charge. When you do have a charge, you're called an ion. So an ion is an atom or a group of atoms with a charge. And we've looked at all different kinds of ions. We've talked about how you become positive, how you become negative by either gaining or losing electrons. In this chapter, we're also going to see ions where we have a group of atoms. So we'll get to that in just a few minutes. Okay, so an anion is a negative ion, and you become negative by gaining electrons. We've seen examples like F -1 or 1 minus. For you, it doesn't matter whether it's -1 or 1 minus. But that just means that you gained 1 electron. O2 minus means that you gained 2 electrons. On the other hand, you have a cation, which is a positive ion. You become positive by losing electrons, which means now you're going to have more protons than electrons. Metals are the players who tends to do this. And we've seen examples like K +1. Remember that we're looking at the top right-hand corner of the periodic table. When you see +1, that really means you lost 1. Ca +2 has mean you lost 2 electrons. Recall we just finished up our periodic table chapter. So in this unit, we talked about how all the metals in group 1, or the alkali metals, have 1 valence electron. They tend to lose that 1 valence electron. So they're going to form +1 ions. The alkali metals have a +2 in the top right-hand corner. So they're going to form +2 ions. We jump across the periodic table. Group 13 loses 3 electrons. They become +3. 14 loses 4 electrons, or can gain 4 electrons. They kind of do both. They don't typically form ions, and we'll look at that when we talk about bonding. Group 15 tend to gain electrons. They're going to have a -3 charge in the top right-hand corner. Group 16 gain electrons, become 2 minus ions. Group 17 gain 1 electron. There are a bunch of examples listed there. And group 18 we've already talked about, do not bond because they are stable. They have a full valence shell of electrons. So these ones in the middle are kind of wacky, these transition metals. They can have more than one possible oxidation state. To show which one we're going to use, we're going to, when we name these, put the charge in parentheses. So iron, number 26, can have 2 oxidation states. In the top right-hand corner, it says +2 and +3. So that I know which one you're talking about, you're going to write the charge. So if I'm talking about iron +2, I'm going to write 2, the number 2, in Roman numerals. If I'm talking about iron +3, I'm going to write the number 3 in Roman numerals. So we're going to use the Roman numeral to indicate what the charge is. There are 2 different methods for how we can name compounds. Sometimes we'll use the stock system, and for the purpose of Regents chemistry, we're pretty much going to stick to the stock system. We're going to use Roman numerals in parentheses to indicate the value. There's also something called the classical system, which uses the root word of the prefixes. So you may see sometimes on the bottles that we use in the lab, like cupric chloride or cuprous chloride. So if you see that, that's referring to the classical method. We won't really be discussing that this year. But other ones do exist, you should just know. All right, so what we're going to start with is how you name a cation, or how do you name a positive ion. When you name a cation, if the charge is always the same, like for example, if you're always going to be +1, meaning that if you look in the top right-hand corner of the box and there's only one possible option, for example, if it's only +1, you just write the name of the metal. Transition metals can have more than one type of charge. We discussed how iron could be +2 or +3. So in that case, you would indicate the charge with a Roman numeral in parentheses. Additionally, there are some metals that are after the transition metal ends, like so after group 12 over here, we have tin and lead that have multiple oxidation states for a metal. So we would also use a Roman numeral in that case to indicate the charge. And then there are some transition elements that only have one charge, like zinc is always only +2, cadmium is only +2, silver is +1. So I don't need a parentheses with the Roman numeral indicating what the charge is. The purpose of the Roman numeral is just to tell me which one we're using. So if it's, if there's only one option, we don't have to put that. Okay? So let's just go through a few examples. Sodium. So you find sodium in your reference table. It's atomic number 11. You look it up. You look at the box, the top right-hand corner. There's only one option, +1. So sodium will just be sodium. Calcium. You look up calcium in the reference table, 1 oxidation state, so we're just going to write calcium. Aluminum. You find aluminum in the reference table. Look at the top right-hand corner. Only 1 option, +3, so it's just aluminum. Next, we look at iron in the reference table, number 26. Iron could be Fe+2 or Fe+3. So now we're going to write iron, and then a parentheses, and then Roman numeral 3. Same idea for the next one. Iron 2, we just mentioned, has more than 1 oxidation state, so you're going to write iron, and then parentheses, Roman numeral 2, close the parentheses. Lead +2, so you look at your reference table. Can lead have more than 1 oxidation state? Yes, so it'll be lead, parentheses, 2, because the charge here is 2. So whatever the charge is that we're trying to write out, we're just going to put that in the Roman numeral. The last one is lithium, and lithium only has 1 oxidation state, so it's just lithium. So if they give you the name of the ion, you're just going to put the name and the charge. So K +1 for potassium +1, because you would just go look up what the charge is in the reference table. The next one is the magnesium ion, so Mg+2, because magnesium only has 1 possible option. We're putting a charge because remember ions have a charge. Copper, Roman numeral 2 ion, means that we're talking about copper +2. Chromium Vi ion, so Vi is 6, so it'll be Cr +6. Barium ion, Ba is +2. Mercury 2 ion would be mercury +2. So as far as anions, they're always going to have the same charge. You're just going to look at the top right-hand corner. For the nonmetals, we're going to pick the top negative number, and we're just going to make the ending of these ions IDE. So a fluorine atom becomes a fluoride ion. So to name anything that is negative, you're just writing the first syllable. So this is chlorine. So the first syllable is chlor. So it's become chloride, nitride, bromide, oxide. So you just take the first syllable and then you just put an IDE ending on this. I almost tricked you down here. I would think this would be galide, but no. It has a +3. So this is just gallium. Just try to see if we could throw you off. So for writing symbols for these, you just would write whatever the symbol is. So S, and then you look in the top right-hand corner, -2. Iodine, I, look in the top right-hand corner on your periodic table, -1. Phosphorus, P, -3. Sr, see how it doesn't end in IDE? That's because it's a positive ion, so it's Sr+2. So going back to how we named the positive ions before, if you're negative, you're going to end in IDE. If you're positive, you're just going to write the name of the element, and if it has more than 1 option, you're going to put that in Roman numerals.